Hello. Yeah. So I was already discussing with you about course projects and research papers and patents. Okay. So now it's more specific. So you have to we have to focus on one research article and one research patent before the mid semester exam, first mid semester exam. Okay. So before the mid semester exam,
Sir, you are muted, sir.
so please remember that you will get one question out of this research article. So if you write like one page summary, I mean a one page research article summary. So that means you will be able to answer one question in the first mid semester exam. Okay, so you should focus on this article and one research patent, which is high corrosion resistant hot dip zinc alloy plated steel sheet. So this is the research patent. You should make one page summary out of this patent, and you will definitely get one question out of this patent in first mid semester exam. Okay, is it clear? Is it clear?
Yes, sir.
Yes. So you will have to focus on one research article and one research patent. Okay, the research patent is high corrosion resistant hot chip zinc alloy plated steel sheet. So this is the US patent. The research article is hydrogen fuel cell vehicles. So these two we have to focus it. Okay. So the rest, so we will focus it on the after first mid semester exam. So that means it's nearly we have 1 month or slightly more than a month. But perhaps so you should make it ready by end of January. The summary of the research article and the research patent. So by the end of January, you should make it ready of your one page summary. Of course, I mean, you have to submit one page summary, but still you can make 2 pages for yourself. So you don't have to stick to only one page for yourself. So you can make it for, I mean, you can make 2 pages notes for yourself, and you can submit for me only one page. Okay, but in one page, so you should have everything, a detailed summary. I mean, you should not miss anything. So whatever you understand, so you have to write it. Even you have to write the introduction, maybe few lines, and the theme. I mean, what is the concept? And last two, in the end, we have to give some conclusions, at least two, 3 sentences. Okay, so focus on this. So whenever you get free time. So even for details, even I have already given the details in the last week itself about this fuel cell vehicles research paper and the research patent. Okay. Yes. Have you watched the videos? Have you watched the videos? Anybody? Anybody? Hello? Hello? Can you hear me?
Yes, sir.
Yes, sir.
Yes. What is your first experiment? Anybody can explain it. What is your first experiment for the lab?
Estimation of hydroxide.
Yes. So how many steps are involved? How many steps are involved? Hmm? Anybody? How many steps are involved in the estimation of hydroxide ions? So how many steps? So if you are like this, you will get 0 marks in the lab. So that means you did not follow the videos, even did not follow the class. Yes.
So 5 steps.
5 steps. What are those?
4 steps, sir.
Aim,
What?
apparatus,
Okay.
procedure,
Yes. Uh-huh. Yes. No, that is the procedure for your lab. So I'm talking about I'm more specifically asking about how many steps are involved in the estimation of hydroxide. So there are 2 steps are involved in the estimation of hydroxide. The first step is, so you have to estimate the concentration of HCl, hydrochloric acid, because that is the main reagent which you are going to use in the titrations. The first step is estimation of hydroxide, and the estimation of hydrochloric. The second step is the estimation of the hydroxide. Okay, what is the formula you use for the estimation of HCl estimation? What is the formula? Yes. What is the formula? Anybody?
HCl.
Yeah, what is the formula you use for estimation of concentrations? Estimation of HCl concentration or estimation of hydroxide. So what is the formula? Yes, anybody? That means you are not following the classes. Hmm? M1 V1 by N1 is equal to M2 V2 by N2. So whatever the values, so you substitute in that formula, then you estimate the unknown concentration. For example, in the first step, so you estimate concentration of HCl. That means a molar concentration of HCl in the first step. In the second one, so you estimate the molar concentration of hydroxide. I think you have to read it. I mean, you are not following the class or you are not watching the videos. Even I have shared you the slides also. Okay, so I think you will have Viva after each lab. So you have to prepare well. I think these are very simple formulas. So you should remember. So I mean the all other classes are already completed 2 experiments. We are late because we have missed one class. So that's why I'm taking the now. I mean for even for the second experiment, because on Saturday, so we'll have to go for the third. Okay, so even the first experiment is very easy experiment, so you are not able to follow it. From now, from second and third experiments are very complex. So how could you follow? Because the first experiment is the starting experiment for the second experiment. So if you know the first experiment, then only you will be able to do the second experiment. Okay, even I have already shared with you so the detailed procedure. Okay, have you read this? The manual. Have you got the manuals?
Sir.
Yes.
So,
Okay. So have you gone through the manual? Because even I have scanned this and I forwarded to you this manual. Okay. So today we are going to discuss about the second experiment. What is the second experiment? The determination of the alkalinity of water. In the first experiment, we have determined the hydroxide in the test sample. Whatever the test sample was like NaOH. So in NaOH solution, so we have determined the content of OH minus ions present. Okay, through volumetric titrations against hydrochloric acid, and we have used methyl orange as the initiator. Sorry, the indicator. So we are going to discuss about the alkalinity of water. So what do you mean by alkalinity of water? Anybody? What do you mean by alkalinity of water? Yes, you have to speed up. You have to respond quickly. What do you mean by alkalinity? Anybody? What is alkalinity? So alkaline means it has the pH is more than 7. If the pH is more than 7, that solution is alkaline. If the pH less than 7, that is more acidic. So you will have alkaline solution, but you have to find out what causes the alkalinity. What are the elements cause the alkalinity of the solution? So for example, so OH minus ions causes the alkaline nature, and also carbonate ions, and also bicarbonate ions. So how? Because there are these are the salts. These are present in the form of salts. Okay. So yeah, these salts are reacted with the. So you will titrate against hydrochloric acid. So this is the base. So acid and base reactions. So there are particular based on the groups, chemical groups present in your alkaline solution, the acid will react accordingly. So then forms ions, OH minus ions and hydrocarbon. So in case, so this, what is the significance of alkalinity? So In case if there is if you take the river water or some sea water, so you can estimate what are the ions present in that particular water sample. That means, so those are the salt impurities are present in water in the form of ions and salts. Okay. So what are the requirements? So you need a conical flask and burette, pipette, and burette stand. So like before in the first experiment. So the chemicals. So you need a hydrochloric acid. So hydrochloric acid is the main reagent. So you also take phenolphthalein and methyl orange as indicators. And you need, so you will have two water samples, water sample A and water sample B, because these two water samples are different alkaline in nature. So you have to find out the alkaline nature of water sample A and alkaline nature of sample B. So that means, so some ions are present in sample A and some different ions are present in sample B. So which causes the alkalinity of the water. So you can estimate this against standard HCl volumetric titrations using different indicators. So use phenolphthalein indicator as well as the methyl orange indicator. So why do you have some indicators? If there is more acidic nature, you can use phenolphthalein. If it is slightly basic nature, you can use methyl orange. It's all depends upon the, there is a pH range. So depends upon the pH of the solution, you can require indicator. So what type of ions could present in the sample to cause the alkaline nature for the sample? So these are the ions. So it could be OH minus ions as a single. It could be single ions, bicarbonate ions, or it could be combination of carbonate and bicarbonate, and combination of carbonate and OH minus. So you have to find out these ions in the sample. It, uh, I mean, so it could be only single ions could present in the sample, or some two ions are present in the sample. We don't know it, so you have to find out with the titrations. So here, in the sixth one, there is no bicarbonate and OH minus. This they are present together in the sample. Why? Because if if they both present in the sample, they can react together and they form water and carbonate ions. If if bicarbonate plus OH minus ion both are present in water, so they react and form the carbonate ions only. So these two ions they disappear it they react and they disappear, and you get their new ion, which is carbonate ion. So that's why, so bicarbonate plus hydroxide ions cannot present in water together. So in the first step, like we have done in the first experiment. So in the first experiment, estimation of hydroxide. So we had two steps. In the first step, we have estimated the HCl. The second, we have estimated the OH minus. I mean hydroxide present in the sample. So in the first one, we have estimated the concentration of hydrochloric acid. Right. So here also in the first step, we have to estimate the concentration of hydrochloric acid. So you have to follow the same here. The first step is standard. It's the same like in our first experiment. So in the first step, so you will estimate the hydrochloric acid concentration. Okay. In the second step, you take that sample A. In the sample A, you have to estimate the ions which causes alkalinity of the sample, titrating the sample against hydrochloric acid, which we have standardized in the first case. So you should not skip this step, because perhaps in the first experiment we have already done estimation of hydrochloric acid. So in this second experiment we should not do it like that. Okay, you should not. I mean, since you have done first week, so you might have think that you don't do it now, but you have to do it again. You have to do estimation of hydrochloric acid in the first step. In the second step, so you take the water sample. I have already told you sample A and sample B. So take sample A, and you have to titrate sample A against HCl by taking these two, phenolphthalein and methyl orange. Sorry, methyl orange is the the pH range is 3 to 4, 3 to 4.5, and phenolphthalein is 8 to 10. So this is basic. So if there is a basic solution, if your solution is basic, so if we add phenolphthalein, so the solution turns to pink color. So then after titration, it will be colorless. If it is basic, if we add methyl orange, so at the basic conditions, so the color of methyl orange will be yellow. If turns to acidic, so it will be the reddish orange color. So based on the color, you will be able to uh, recognize acidic nature and basic nature of the solution. So these are the reactions of carbonate ions. So when you start titration with HCl against your water sample, which contains carbonate ions. So carbonate ions reacts with HCl, it forms bicarbonate ion plus chloride ions. Okay, so in case waste minus ions are present in the sample, so it could react with hydrochloric acid. It forms water and chloride ions, but because we are not going to estimate the chloride ions here, so we are going to estimate the carbonate, hydrocarbonate, and OH minus. This basic which the ions which have basic in nature. So in case if there are hydrocarbonate ions are present in the sample, so they can react with HCl. It forms CO2 and H2O. So this is gas, then this water, again the chloride ions. Okay, so based on ions, so on their reactions, so you will be able to estimate the types of ions present in your sample, which causes alkalinity. Okay, so in the first titration, so you use phenolphthalein as indicator. Okay, so you add phenolphthalein as indicator, so the solution turns to pink color. And then after when you start doing the titration, so you have to titrate until you get colorless solution. So you have to note down the values in the table. So the HCl reacts with the OH minus ions. So these are the equations. The OH minus ions and CO3 2 minus ions. So they can react with the acid and it forms hydrocarbonate ions. Okay, so in this table, so whatever you get the value on the right hand side, the table, maybe I will show you in the next one. Yeah. So this is the table for water sample. So first we have added phenolphthalein indicator and we have done the titrations again. So this is a sample here. We have prepared out 10 ml in conical flask. So it's hydrochloric acid you took in burette. Okay. So the final reading value is, so you got like 5.6 ml for example. Okay. So this is your term as P. This is your P. Then in the second one, take the same water sample. Okay, add methyl orange. So you pipette out 10 ml of water sample here. Add methyl orange indicator. Okay, so then again do the same titration. So we'll get certain value. So which is for example 11.1. So this is you can term as M. So since it is a phenolphthalein, this is P. Methyl orange, this is M. Okay. So P, this is the a table. So do which you can use this table to determine the alkaline nature of your sample A. So here you got the values. P is equal to 5.6, M is equal to 11.1. So which this values you got it above table after titration with hydrochloric acid. So based on relation between this, okay. So before going to relation to this two, so with hydrochloric. So what could happen when you titrate with HCl or with your sample and HCl? So here it is clear that in the first step, the neutralization of hydroxide ions and off neutralization of ions. So when you titrate in the first step, taking water sample A and titrating against hydrochloric acid can form a hydrocarbonate. OH minus ions could react with HCl and water. So that means there is a and there is off neutralization of carbonate ions because carbonate ions are neutralized. So that means this is called half neutralization. There are ions, but the ions reacted with HCl form different ion. So this is not fully satisfied. This is not fully neutralized. Okay, so this after OH minus, that is your first react. Okay, in the second table, so you have titrate against HCl and your water with methyl orange indicator. So at these conditions could have this hydrocarbonate ions follow complete in the second iterations. But in the all these actions can occur in the second step. In the first step, there is reaction one, reaction two can occur in the first titration. In the second titrations, all three reactions can occur. Okay, or complete neutralization of hydrocarbon ion and complete neutralization of OH minus ions, but there is off neutralization of CO3 2 minus. But again, this there is a formation of CO3 HCl, and it could also have complete neutralization. And this value can term as M, because in case the all three could present. So based on relation between P and M, you'll
Sir, you're not audible, sir.
సార్
సార్ మీటింగ్లోనే లేడు.
అవును
వర్ష
విద్య
సార్ ఫోన్ కూడా బిజీ
హలో సిఆర్,
సార్ ఫోన్ బిజీ వస్తుంది.
వదిలేసాను చేయకండి ఫోన్.
సార్ ఇంకా అటెండెన్స్ డౌన్లోడ్ చేయనట్టున్నారు. ఒక 2 minutes ఆగండి.
అటెండెన్స్ అద్దా
విద్య ఏం చేస్తున్నాను?
వర్షం మళ్ళీ ఒకసారి ట్రై చేసి సార్కి ఒకసారి కాల్. సార్ జాయిన్ అవుతాడంట. నెట్వర్క్ ప్రాబ్లం ఉందంట. ఒక 2 minutes జాయిన్ అవుతాడంట.
ఓకే.
అసలు సార్ చెప్పేది ఏమన్నా అర్థమవుతుందా ఎవరికన్నా?
Roll number 76, 81, 87. Hello. Hello.
Yes, sir.
Hello. It's audible.
Yes, sir. Yes,
Yes, sir.
Audible, sir.
Hello.
Sir, your voice is not
You are
clear.
audible, sir.
Yeah. Okay. 76. Roll number 76. Yes. 76, 81, 80. They are absent. Eighty-one, 87. Okay. So where we are? Yeah. So could you follow this? P is equal to m by 2.
No, sir. It's not
So
visible.
that means only carbonate ions are present. Okay. So in this P is equal to less is not visible.
Yes, sir. It is not visible.
Can you see your slides, sir?
Slide is not visible, sir.
Yes. Is it visible now?
No, sir.
Yes, sir.
No. No. Because
Visible, sir.
I have
Visible,
already
sir.
shared it. Yes. Okay. So the third is good. So that means what? So that means there are only 3 carbonate ions are present. Okay. So in case the P is less than m by 2 value, so the P is equal to 5.6 and m is equal to 11.1. In case the P value is 11.1 and bicarbonate ions are present in the sample. So if P is equal to greater than m by 2, voice is not clear?
No, sir.
Hello? Yeah.
Voice is not clear.
Yes. Not clear.
Yes, sir, not
Yes, sir,
clear.
not
It's not clear. Because I have using, so I got increase the value. Is it clear now? Hello?
No, sir.
Hello? Hi, is it clear? No, then shall I do? Okay, wait a minute. I will change the network.
Sir, it's not clear.
Hello, sir.
Sir was exited maybe.